Now, a question this time, we've got a particle that's projected from H at an angle alpha and at a velocity v, and it's hitting at a point P at makes this angle here inverse tan of 2 tan alpha. And we want to find its speed of the projection and OP. So we want to find what's its speed, so V there, and what's the distance there, OP, in terms of H and alpha. So the H, which is the height there, and alpha. So we want to work out that. We take that to be beta there, because that'll allow us to manipulate. So that's what it looks like. So what we get is these two statements. Now we know how to get these two statements. We start with the acceleration being equal to 0 and then manipulate it through. And our velocity initially is v cos alpha, and our vertical velocity initially is v sine alpha. We project it from h, so that's where the h comes from there, and this started from the minus g, and we've integrated to get to those 2 points. So we assume that you know what we do and get those ones. So seeing O is the foot of the cliff and OH is H, OP is the distance, as we said, to the foot of the the place where it hits. So we need to start establishing some of these. So a particle hits the ground at y is equal to 0. So we can set that equal up to y there, and we establish we've got a quadratic there. If we solve that quadratic, we get v sine alpha plus square root of v squared sine squared alpha plus 2gh on g. We only take the positive because yes, we would get 2 spots, but we want the positive. The negative one would be before time existed, so we ignore the negative there on our quadratic. So therefore, we get this situation. If we put t and sub that in for t, we get the v cos alpha times t, and that would give us our distance of OP. So now we need to establish the velocity, because we wanted to get v and OP in terms of h and alpha. So we've got OP, but it's still got v in there. So we need to find our value of v. So we know tan beta here, and we establish that as the vertical velocity on the horizontal velocity, and we know that tan beta would be equal to minus 2 tan alpha, because that's how it was set up before. So minus 2 tan alpha could be set up as the vertical velocity on the horizontal velocity. So we can set up our equations here, because the vertical velocity is v sine alpha minus gt, the horizontal velocity was v cos alpha, and that's equal to minus 2 tan alpha. Well, let's multiply through by cos alpha and v, and we get minus 2v sine alpha. So the tan alpha multiplies by the cos, and the coses cancel. So v2 minus 2v sine alpha and the v sine alpha minus gt. So we can set up t being equal to 3 sine alpha on g times v. So we just manipulate it, get t there. Now if we take equation 5 that we've just established there, and what we had in 3 before, because they're both equal to t, we've equated those. Our g's will cancel, and we get 3 sine alpha times v, and because it's over nothing there, we can subtract our v sine alpha there, which gives us 2 sine alpha times v. Now we're trying to solve for v, so we need to get rid of the square root. So that goes, so we square both sides, and this is where we move to our equation here. So v squared 4 sine squared alpha, because that's been squared there. And we've got this side, which is the v squared sine squared alpha plus 2gh, and we're solving for v, so we take our v squareds across, gives us 3v squared sine squared alpha, and the 2g equals to 2gh, divide by the 3 sine squared alpha, and then take the square root again and everything to get v is equal to the square root of 2gh over the 3, and the 1 on sine alpha separate, because that was already squared. So there's v in terms of g and h and alpha. So now we can express OP in terms of h and alpha, because we've got a value for v that we sub in, and the t and all those values. So we can get an equation where it's just in terms of h and alpha. So we've got, we do our substitution there, and then we start to try and clean this up a bit. So we're able to get the G out. So cos on sine becomes the cot alpha on G. We're going to multiply through by square root of 2gh on 3 because, well, that will get rid of that part there for us. The square root goes, and we get square root all this times each of those terms, 4g squared h squared on 9, 4g squared h squared on 3. Get a common denominator, and we get 16g squared h squared on 9, which is nice because that takes the square root and gives us 4 on 3 gh, which we collect our terms in, and that's going to give us the g's cancelling. We get 2 plus 4 gives us 6, which is 2. When we 6 over 3 gives us the 2h, and we end up with 2h cot alpha. So it comes down to something quite nice. And question 4 here, we've got a particle that's projected from 0 at time t is equal to 0, speed v at an angle alpha, and it moves under gravity, reaches its horizontal range at time t. So if the line OP at a certain point of it makes an angle gamma below the horizontal, so it goes past the horizontal, and such that we get tan of gamma is equal to 1/3 of tan of alpha. Show that time must be equal to 4 on 3t. So again, we establish our two equations. We start from the origin, so there's no constants we have to deal with there. And so that's what we're talking about. Point P here is where we get tan of gamma being the y on x value. So we can establish tan of gamma, which was 1/3 of tan of alpha. That's what was set up there, equal to our y on our x value. So we get the y on the x value there. And we took the absolute value because we just wanted what the distance was. We didn't care where the position was. And we know because it's below the axis, y would be negative. So that's where we get the gt on 2, gt squared on 2 minus 5v sine alpha times t. And so we've got our 1/3 alpha. We manipulate our equation through here. We just do all the algebra that's involved. We get gt over 2v cos alpha minus tan alpha, which we're going to add on both sides, gives us 4 on 3 tan alpha. We're going to multiply through by 2v cos alpha and divide by g to get t by itself. So we get the cos starting to cancel with the tan. So it gives us the sine alpha. The g's on the bottom. We got our 2v on top. And we know that for 2, when y is equal to 0, t was equal to t. So we're able to establish that, well, y is equal to 0. We can put t is equal to 2v sine alpha on g. But we can solve that. So therefore we can see that the time there would be 4/3 of whatever t was. So it hit that point at that time. And so the time where it hits P will be 4 on 3, lots of that, which is what we wanted to establish.